So, what is internal energy? Internal energy. Actually, internal energy is the energy content in a material. Okay, this is what internal energy is. In some books, it is written that the energy that is required to do the work, okay, that is supplied from a material to do the work, this is internal energy. Okay, so mainly, how can I define internal energy? Is that suppose this is a material, okay, we have some atoms, okay, see, we have a particular distance between the atoms. If we have a particular distance between two atoms, we know from Newton's law, a very negligible force, as the mass is very negligible in this case, will act between them. And if there is a force, there is a potential from this relation. I hope you know classical mechanics from your first year. I don't know in which year you are in, but there is a relation that F is negative grad of V. So, okay, so there is a potential energy I can see, okay, in the material if there is a distance between 2 points. Okay, so this is V, or okay, V, or you can write U, potential energy. This atoms can move within the material if we apply some of the heat or something else. So this is moving, it's moving with a velocity, and a mass moving with a velocity gives rise to kinetic energy. So we have another energy, K. Okay, and if we give some heat to this material, it may, if we don't give heat, I mean, it comes, it is in some temperature, okay, some 25, 26, some of the vibrations will take place, some of the molecules will move. I'm not talking about that heat supply from outside, right? I hope you can get my point. So that is K, that is kinetic energy, and I am telling you vibration that will give rise to the vibrational energy. Like this, you might have the rotational energy. All this energy sums up to give the internal energy. So that energy content within the material is internal energy. Okay, chalo. So first law of thermodynamics. What is the first law of thermodynamics? Energy can neither be created nor be destroyed. This is very easy, but we have to emphasize on the mathematical thing. So this is dq equals to du plus dw, or I remember like this, du equals to dq minus dw. Okay, so du equals to dq minus dw. This is the first law of thermodynamics. You know the terms. Du is the change in the internal energy, the change in heat, and the work done is dw. Easy. So this is the first law of thermodynamics. You have to remember this thing. This is the main thing. So we have several thermodynamic processes, you know, adiabatic, isothermal, isobaric, isochoric. These four processes are of immense importance in thermodynamics. So if du equals to dq minus dw for adiabatic, for adiabatic, heat content, that is change in heat, is 0. So in that case the first law of thermodynamics becomes du equals to minus dw. For isothermal, what is isothermal? There is no change of temperature in the entire process. What is the process I am speaking about? Suppose you are uh, what can I say, pushing a piston like this. Okay, you are giving a pressure to these gas molecules. This is a process. So if you do this and the temperature remains constant in this process, then the system, then the process is known as an isothermal process. Same, if you do this, if you follow this process and if the heat content is 0, then this is adiabatic process. If the volume remains the same, there is no change in volume, delta V equals to 0, then that is known as isochoric process. If the pressure remains same, that will be known as isobaric process. You know, barometer pressure in class 11, I think you have done barometer experiment. We had done it. I had done it in class 11. I have remembered that. Okay, whatever. Barometer, so relative to pressure, so it is isobaric, and for volume it's isochoric. So what is isothermal? The temperature remains constant, so delta U, that is there will, and as U depends on T, I will come in this things in details, it will be 0. So our first law becomes del Q is equal to del W, right? Yeah, if this is 0, this equals to this. Yes. So this situation is very important in case of isotherm. I think IIT Kharagpur gave this question directly in 2019 JAM. Delta U equals to what is the value of change in internal energy in isothermal process or cyclic, whatever is written. Okay, in cyclic process and isothermal process, this internal energy remains constant. Remember this, cyclic and isothermal. The question was somewhat like this. I need to check, and I will obviously discuss previous year paper. So let's go to, I already told, isobaric and isochoric. Isobar means pressure is a constant, and isochoric means volume is the constant. And if pressure is a constant, the equation remains same, and if V equals to K, that is the work done will become 0, as this is 0, there is no change in the volume, so dW equals to 0, and we are having del U equals to del Q for isochoric. Okay, so this is the various form of first law of thermodynamics in various kinds of systems. Also for cyclic process, this isothermal condition will prevail. So this is all about the first law of thermodynamic basics. We are going to study more in the next video. So thanks for watching the video.